So we've just seen a short history of AI, and now the question is, where are we now? Well, let's let you vote. We'll do a little quiz. Which of the following things can we do at present? Can we create a machine which plays a decent game of table tennis? Raise your hands if yes. Yes. Can we create a game that plays a decent game of Jeopardy? Yes. Many of you saw this decent game. It was okay, right? The computer did okay. Okay, we'll actually talk more about Watson later. Can we build an AI that will drive safely along a curving mountain road? Yes. Can we build an AI that will drive safely along Telegraph Avenue? I'm not sure I can drive safely along Telegraph Avenue. So the answer here is actually tricky. We'll come back to autonomous driving a couple times in this course. I'm going to put a question mark here. Telegraph Avenue is particularly difficult, and we can't just have a car which does everything a human can do. However, there are autonomous cars out there driving. They are among us, and they have a plan. In fact, we'll talk a little bit about, for example, the Google autonomous driving cars, which, under the right circumstances and with tools that a driver does not have, are in fact able to drive on real roads. Amazing progress. One thing that's really cool about this list, I've been using this list for years, and kind of every year or two, some X turns into a question mark or a question mark turns into a check. It's really cool to watch. Can we build an AI that will buy a week's worth of groceries on the web? Yeah, it's kind of almost not even AI, right? Can we build an AI which will buy a week's worth of groceries at the Berkeley Bowl, right? That's a little harder, right? You got to navigate around carts. This is probably something that we currently cannot do. And this is an illustration of the decision problem, what do I buy, being tangled up in the action in the real world, which involves not bumping into people with your cart. To operate in the real world in an actual mobile platform often mixes all this stuff together in a very challenging way, where the decisions you make happen at multiple levels of abstraction. Can we build an AI that will discover and prove a new mathematical theorem? Raise your hand if yes. Raise your hand if no. Okay, so I'm going to put a question mark. We can, in fact, build amazing theorem provers that can prove new theorems. Discovery, not so much. Why is this hard? So it turns out if I state a theorem and it's true, we can build automated methods of proving that they are true through computation. It's a lot harder to just ask the computer, tell me something awesome about algebra I don't know, right? Because it could be like, hey, wait, I got it. 10 plus 3 is 13. It's true, right? But you don't know what's interesting. So it's very hard to characterize what makes a theorem interesting. In some sense, it's easier to prove something that's true than figure out what should be proven. Can we build an AI that will converse successfully with another person for an hour? It depends a lot on the other person, right? Some of you may have heard of ELIZA. We'll talk a little bit about ELIZA when we talk about natural language later in the course. But for most people, the answer is no. For some people, the answer is yes. You can converse with some of the people for some of the time. I don't know. But the point is, in general, we cannot yet do this. We cannot yet have computers that have full conversational ability on any topic, just like a human would. How about, can we build an AI that can perform a surgical operation? Who says yes? Okay, raise your hand if you would let an AI perform a surgical operation on you. Would you let an AI remove your kidney? Right, okay. Where did all the hands go? So, that illustrates one of the issues. The answer here is a little complicated. Yeah, we have computer-assisted surgery. Computers are starting, including some cool stuff in Peter Abil's group, starting to be able to tie knots in an automatic way. You can do things like track the movement of an eye if that's in eye surgery and things like that. However, it is not yet the case, both in technology and in cultural kind of willingness to undergo the experiment, that we're going to be having computers swap our kidneys around. Can we build an AI that can put away the dishes and fold the laundry? Yeah, we can build it right here at Berkeley. So I will show you a little bit later some of, again, Peter's work on folding. We can do that. Translate spoken Chinese into spoken English in real time. Raise your hand if you think we can do it. Yeah, we'll talk more about translation and real-time translation later, but we can basically do this. Now you say, wait, is it good English? I didn't say it was good, I said it was spoken, right? But we can do real-time recognition, translation, synthesis. That is something we can do, better than you probably think. Can we build an AI that will write an intentionally funny story? Who thinks yes? I'm going to say no. It's an open area of natural language processing.